Graphene-enhanced lithium-ion batteries and all-solid-state batteries, or ASSBs, are often described as the breakthroughs that will finally ease our dependence on chargers. That promises faster charging, higher energy density, improved safety, and better thermal control. While those benefits are real, the transition is not happening all at once in every flagship device. Instead, the shift is unfolding in a strategic, step-by-step way, beginning with small, premium, and highly specialized electronics before expanding into mainstream smartphones and laptops later in the decade. Companies such as Samsung in South Korea, Apple in California, and Dyson in the United Kingdom are among the major players investing heavily in these next-generation battery technologies. This video follows the practical path these batteries are taking from research to real products. It looks at which companies are leading development, where early trials and limited deployments are already happening, and why wearables and compact accessories are becoming the first proving grounds. It also explores how manufacturing cost and scale determine which devices adopt the technology first. Then outlines the realistic timeline for when graphene-enhanced and solid-state batteries begin appearing in high-end phones, laptops, and eventually wider consumer electronics. But before I start, please consider hitting the like button and subscribing to my channel by the end of this video. It only takes a second, and it really helps support my work. Thanks for watching and helping me get to 1,000 subscribers. Okay, let's begin. In the smartphone world, Samsung Electronics in Suwon, South Korea, has been one of the most visible players in graphene battery research. Its much-discussed graphene ball work has focused on improving lithium-ion batteries with graphene materials to enable faster charging and better thermal performance. Despite years of research, no commercial Galaxy smartphone yet uses a true graphene battery. For now, this remains an R&D pathway rather than a product feature. Samsung is also grouped by industry analysts with Apple in Cupertino, California, and Dyson in Malmesbury, UK, as key investors in all-solid-state battery development for consumer electronics. The expectation across the industry is that ASSBs will reach premium smartphones and laptops around 2027 and beyond, but only after they are proven in smaller devices. There have also been boutique efforts. Appear Inc., a smaller consumer electronics brand, announced a 5G smartphone using a graphene fast charge battery and previously sold a graphene-based Super 20 power bank. These examples show that graphene-enhanced batteries can work in phones, but at a niche scale rather than as part of a global flagship ecosystem. Meanwhile, heavily promoted concepts such as a so-called Tesla Pi phone with week-long battery life remain unconfirmed and are not supported by credible roadmaps from established OEMs. These are better viewed as speculative marketing than near-term consumer products. The most advanced and concrete push into solid-state batteries in consumer electronics is happening in wearables. Samsung Electro-Mechanics, also based in South Korea, is developing compact all-solid-state batteries specifically for small devices such as the Galaxy Watch and the Galaxy Ring. The company is already producing prototypes and running tests with customers, with a target of commercial mass production by the end of 2026. In early generations, the focus is expected to be on faster charging and improved safety, rather than dramatic jumps in battery life. In other words, users may notice much shorter charge times and better durability before they see huge increases in runtime. Other major companies, including Apple and Dyson, are widely identified in market reports as leading investors in solid-state batteries for wearables, smartphones, and laptops. While specific product names and launch dates are mostly undisclosed, the industry consensus is clear. Wearables in the mid to late 2020s first, phones and laptops later. Tiny devices such as true wireless stereo earbuds, smart rings, fitness bands, and compact accessories are especially well suited to both graphene-enhanced lithium-ion and solid-state cells. These products need very small, safe batteries with modest capacity, making them ideal early adopters while manufacturing volumes scale up. For high-end laptops and tablets, companies such as Apple and Samsung are seen as future adopters of solid-state batteries once the technology matures. Market analyses of the ASSB sector frequently list smartphones, computers, and wearables as the main application segments, with total consumer electronics solid-state battery revenue potentially reaching tens of billions of dollars by the early 2030s. Adoption in laptops is expected to follow successful deployments in wearables. Once manufacturing yields improve and costs per kilowatt-hour fall, premium notebooks could use ASSBs to deliver thinner designs, better safety, and higher energy density. Graphene-enhanced lithium-ion cells are already appearing in accessories such as high-end power banks. Some products use graphene composite 21700 cylindrical cells to improve energy density and fast charge performance. Active pilot activity is most visible in Samsung's wearable battery program. Samsung Electromechanics is building prototypes and testing compact solid-state batteries with customers ahead of its planned 2026 commercial entry. Early field trials and limited-run devices are expected before large-scale global production, particularly in South Korea and selected international markets. At the same time, graphene-enhanced lithium-ion technology is quietly being integrated into existing battery supply chains. Because graphene can be used as an additive in anodes or cathodes, manufacturers can improve conductivity and thermal management without completely redesigning battery factories. This makes consumer electronics, including phones, laptops, wearables, and drones, a major testing ground. Small-scale commercial products such as graphene-based power banks and boutique smartphones effectively act as live demonstrations of these materials in the field, even if they are not labeled as trials. From now on, and through 2026, more graphene-enhanced accessories and niche devices are expected, alongside internal pilots in wearables and handheld electronics. Solid-state activity in consumer electronics is still largely in prototyping and customer testing at this stage. Around 2026 to 2027, Samsung's wearables could become some of the first widely recognized consumer products using solid-state batteries, if its production targets hold. Early premium and limited-run devices, such as advanced wearables, AR/VR headsets, or rugged handhelds, may adopt either solid-state or graphene-enhanced packs as headline features. In the late 2020s, broader solid-state adoption in high-end smartphones and laptops is expected, driven by companies such as Apple and Samsung once cost and manufacturing yields improve. Graphene-enhanced lithium-ion is likely to spread more widely across mainstream consumer electronics as production becomes cheaper and integration into standard cell formats matures. Beyond 2030, solid-state batteries in consumer electronics are projected to reach a multi-billion-dollar market scale, with widespread use across phones, laptops, and wearables. Graphene-based enhancements are also expected to become common in devices where fast charging and thermal control are critical. Solid-state batteries are currently significantly more expensive to manufacture than conventional lithium-ion cells. That cost difference is the main reason they will first appear in premium devices, where higher prices can be justified by improved safety, energy density, and marketing appeal. Over time, economies of scale are expected to reduce costs and allow these batteries to move into mid-range products. Graphene-enhanced batteries also carry a price premium today because graphene materials remain relatively costly. Their value is centered on faster charging, better heat management, and longer cycle life rather than the lowest cost per kilowatt hour. As graphene production scales, pricing is expected to improve. At the device level, this means early solid-state or graphene options will likely debut in Pro, flagship, or premium models of phones, watches, and laptops, before filtering down as manufacturing matures. Graphene-enhanced and solid-state batteries are indeed moving toward real consumer products, but the rollout is evolutionary, not explosive. Samsung, along with Apple and Dyson, are central players, with the most immediate impact expected in wearables and small accessories rather than mainstream smartphones. Wearables such as the Galaxy Watch and Ring are poised to be early showcases for solid-state batteries, focusing first on faster charging and safety. Graphene is already appearing in niche devices and accessories, proving its technical viability while the ecosystem scales. Smartphones and laptops will follow later in the decade, especially in premium tiers, as costs fall and manufacturing improves. The future of consumer batteries is coming, just in small, high-end steps before it becomes the new normal. What do you think? Leave me a comment, then go and check out some of my other videos. You might just find something that interests you. Don't forget to hit the like button and subscribe. Thanks again for watching until the end, and we'll see you at the next one.